Good evening. Good evening. Now we will see second part of this, how we will plot BMD on tension side and compression side. Here we are with two problems. So we have this beam with UDL proper cantilever, and we have this when we will say proper cantilever. So second support we should have always roller support. So we have this support as roller support. So now this is given beam. Now value of MAB, this is actually if we will calculate, this is WL square by 8, and that we will get it as MAB. So due to simple support also we have same value. So this is by solving problem and we will get moment at this, and this moment we will get that is equal to 225 kilonewton meter. We are interested to plot BMD on tension side. Now in this case, so we will get again two diagrams. So if I will plot two diagrams separate, so we will have this as 225. Now this is due to fixed end moment, and we have this as 0. So this is for fixed end moment, and how we will get this diagram, then it will go up. So again triangle, and it will be 0. So this is 225. So you can see we have plotted already this by orange color. Now second we have simple support moment diagram. So we will plot it as WL square by 8. So we have WL square by 8. And then we will have this diagram we are going to plot. This is on compression side, because this is 50 and 50 into 3 we will get it as 150, because 50 into 6 half goes on both sides. And then if we will plot at center, then we will get it as 150 into 3. This is 3 meters, and we have this as UDL. And then from this, if we will plot this value, so this will be 150 into 3 clockwise minus 50 into 3 into 3 by 2, which is anti-clockwise. So we will get it as 450 minus 225. So this is 225. But this is clockwise. So if I will plot it as clockwise, because we are finding plotting this due to moment. And then this will go up, and we will have this as 225 plotted by blue line. So we have this will be 225 kilonewton meter. Now if we will plot on tension side, then we will have this as 225. So 225 minus 0, because we have due to free BMD 0, and this is 225. So I will plot it as 225. Now we have this point where we will get this value as 0, and then at the center, if we will calculate, so at center this is we have value half of this. So this is 225. If I will consider this as a triangle, and this is 225, and we are going to find out at center, we will get it as 225 by 2. In last problem, if we will see, then we have this value. So I forgot to explain that how we will get 51.84. So we have this value 86.4, and now we have to find value. So at 2 meters, because we have load at 2 meters. So here I have to find out, and this from 0 height we have this as 3 meters. Then we are interested to find this value. Then how we will find this? So we will get this as y. So y equal to 86.4 upon 5 into 3, and then we will get it as 51.84. That we have taken in last example. So under this we are by using similar triangles. So this value we are going to get in this case as 225 by 2, and that is 112.5. Now net value, if we will calculate 225 minus 112.5, due to blue we have to plot below, because that on tension side, and then we will get it as like this. So till this we have, that is due to fixed end moment, and therefore we have plotted it on upward side, and then remaining portion we have due to blue line, and therefore we have to plot it below, and then we will have this diagram 112.5 kilonewton meter. Now instead of superposition, if you have to plot directly on tension side, then how we will plot this? Then we will have this. So this value we have 225, and then we have in this way. So this value we have 50 kilonewton per meter. Now if we will calculate a reaction, if we will calculate reaction at any point, suppose, or I know this reaction I have 3 by 8 WL, and this reaction I have 5 by 8 W into L. So this value, if I will calculate it, then I will get it as 3 by 8 into W is 5 and L we have 6. And then we will get it as 2, 3, 2, and that is 25. So this will be 4 and then 2 will be remained. And then we will have 225 by 2, 112.5. Now if I will plot it first due to fixed end moment. So we have moment, we have an anti-clockwise, and this is moment, and because this is anti-clockwise moment, if we will plot fixed end moment, so this is fixed end moment which is clockwise, and it will take beam up. What will be value over there? So value I have 225. Now we will find at center, and I will find from right side. So from right side, how we will get this value? So we will, or you can go from left side also. That is one and the same. It becomes easy to understand. So we will have this 112.5, and this is 50 into 6, 300, and 300 minus 112.5, and we will get this as 0.5372 187.5, 187.5, and then you have this moment 225, and then you have UDL. Now you calculate this value, you will get this value as clockwise, and as you will get it as clockwise, due to moment it will go up, and if we will plot fixed end moment, then you have to consider it as anti-clockwise. This value you will get, that is equal to 112.5, and then that will be downward, and then you have to plot it. So likewise, so this value we will get it as 112.5 kilonewton meter. Now this point where it will cut the axis, this is known as contraflexion. Contra means opposite. So this is the point where your bending moment becomes opposite, and that you can find by taking portion that is equal to 0. Means I have to consider this. So I have this value that is equal to 225. Reaction we have 187.5. This is X, and we have W over here. And then by this we will have bending moment equal to 0. That is equal to minus 225 plus 187.5 into X minus 50 into X square by 2. And this quadratic equation you can find for X, that will gives you point of contraflexion. So likewise we can go for BMD on tension side. So we will have this BMD, and this BMD we have BMD on tension side. This BMD. Now next we will have one, this is one beam, then we have MA and MB, we got it as fixed end moment, we got it as clockwise. Now how we will have clockwise? Then you can go to fixed beam, which we have to go for fixed beams which we have in this mechanics of structures, and there you will get these both reactions as m by 4, and that is clockwise. Now how we will get BMD by superposition? Now try to understand how we will get. Now first we will have fixed end moments. So we will have this fixed end moment, that is m by 4 clockwise, And then this fixed end moment also we have m/4 clockwise. Now both are going to take your beam below, and therefore if we will see, then we will have diagram in this fashion. Again it should be triangular or trapezoidal, already we have seen. And then second we have, that is pre-BMD, and then we will have this as, now you can see this. So we have moment at center. Then what will be reaction? So this is clockwise. So this reaction I will get it as m/L, and this also I will get, but in downward direction, because summation Fy0, and then we will get downward. So if I will say this as RB, and if we will take moment about A0, then we will have RB into L minus RB into L plus M equal to 0, and we will get RB is equal to m/L, and we have this reaction. Now if we will plot BMD, now this is due to simple support, so we will get m/L. So this will, we will have m/L into L/2, and this will be m/2, but it will go down. Now if we will plot just right of m at this point, then what we will get? So we will get this as m/L into L/2. This will be anti-clockwise, plus m, and we will get plus m/2 clockwise. Now you plot clockwise. So how I will get this diagram? So just left of m I have below, and just right of m I have up. So likewise, then you can see over here. Now what will happen? So we have to go now the final moment diagram. Now this is on tension side itself, m/4. So this m/4, this m/4, we will get it as m/4, and then at junction we have this value. So now you can see, we will have this as m/4, then this portion. Now this, whatever portion we have common, that we have subtracted. So this portion we have subtracted. So here m/4 minus 0, m/4. At this point we have this value 0. So this is m/2, but this is on compression side. We have to plot on tension side. So it will go up, which will be m/2. Now this we have to plot on tension side. So this we have to plot below m/2, and this will be again as it is. So these common portions we have subtracted, and then we are going to get this BMD on tension side. So we have to plot like this. Now if we will try to plot this, so you can see this, we have this value as m/4. Now value we have here, that is reaction, which is m/L. Now just left, if we will calculate value, then what I will get it as, so I have minus m/L into L/2 plus m/4, and we will get it as m minus m/2 plus m/4 minus m/2. Minus m/2 means we have anti-clockwise, and then we have this value that is anti-clockwise. So we are in this fashion. Now we have to, this is due to moment which will come down. If I will go for fixed end moment, then it will be clockwise. That will take your beam up, and you can see. So we have m/4, then likewise we have m/2, and then if we will go right, then we will have this m/2, and then this m/4. So this is BMD on tension side. So likewise we have to solve the problems which are related with your BMD by superposition and BMD on tension side. So I have taken all three examples: concentrated load, then UDL, and couple. So we will stop here only. So thank you.